Look at almost any major galaxy in the universe, and you will find the exact same architectural rule. A supermassive black hole sits firmly anchored right at the center, holding everything together. Our own Milky Way follows this rule. Dead center in our galaxy sits Sagittarius A star, a supermassive black hole weighing roughly 4 million times as much as our Sun. Because galaxies grow around these massive cores, physics dictates they should stay put. But imagine what happens if one of these central objects slips its gravitational leash and simply wanders away into the dark. In November 2025, a wide sky scan by the Zwicky Transient facility detected an exceptionally bright flash of light deep in the distant universe. Every single night, observatories like this one record around 500,000 transient events, objects that suddenly brighten or change in the sky. Since no human team can inspect that many signals, astronomers rely on a machine learning algorithm called TDS score to filter out the noise and flag the real anomalies. This map highlights a glowing point representing the AI's flagged flare. But look at the distance from the galactic center. This massive energy burst wasn't coming from the core. It was located over 30,000 light-years away, deep in the galaxy's outer suburbs. Supermassive black holes aren't supposed to exist out there. Finding one so far from the center breaks our established models of galaxy formation and forced scientists to figure out exactly what was surviving in the galactic outer limits. The anomaly, TDE 2025 ABCR, was incredibly violent. At its peak, this flare radiated with the combined light of about 10 billion suns, outshining its entire host galaxy for several months. The massive object generating this light, a wandering black hole weighing roughly 1 million solar masses, emits no light of its own. It was completely invisible until an unlucky star drifted too close and triggered the eruption. If you were flying a spaceship towards this anomaly, do you think you'd even notice the gravitational distortion before crossing the point of no return? This graphic shows the mechanics of that destruction. As the spherical star approaches the dark center, gravity pulls exponentially harder on the star's leading edge than on its far side. This massive imbalance of gravitational forces literally stretches the star out into a long, glowing stream of particles. Astronomers call this process spaghettification, and the resulting destruction is known as a tidal disruption event. Instead of disappearing instantly, that stellar debris wraps tightly around the dark center, forming a rapidly spinning accretion disk. As that material superheats, it generates a massive burst of ultraviolet and X-ray light that telescopes can detect hundreds of millions of light-years away. Because black holes trap light, they offer no direct visual evidence of their existence. We can only map the universe's heaviest invisible objects by waiting for them to consume and destroy visible matter. But finding the black hole only answers half the question. The lingering physical mystery is how an object weighing 1 million solar masses gets displaced from its galactic core. Astronomers currently favor two theories. This first model illustrates the gravitational slingshot. When two galaxies collide, their central black holes fall into a decaying orbit with one another. If the gravitational dynamics line up perfectly, one of those black holes can be violently ejected outward, flinging it into the galactic suburbs. The second model is the naked dwarf theory. In this scenario, the black hole was never actually ejected. Instead, it was always the core of a tiny dwarf galaxy. Over billions of years, a larger neighboring galaxy consumed the dwarf, stripping away all of its faint stars through tidal forces until only the central black hole remained. Which of these two scenarios makes more logical sense to you? A gravitational slingshot or the remains of a swallowed galaxy? Let me know your theory in the comments. Right now, neither explanation has been confirmed, but proving either theory will give us a precise historical record of how galaxies interact, collide, and consume each other over billions of years. Up until this discovery, astronomers almost exclusively scanned the centers of galaxies when searching for tidal disruption events. Now they know rogue supermassive black holes can expose themselves far from the core, entirely out in the dark. This realization points to a massive opportunity for the next generation of wide sky surveys. Facilities like the Vera C. Rubin Observatory will apply these off-center tracking methods to hunt down entirely hidden populations of wandering black holes. They won't be looking alone. NASA's upcoming Nancy Grace Roman Space Telescope is being assembled to join this hunt from outside Earth's atmosphere, mapping these rare events with extreme precision. If a 1 million solar mass monster was exposed by cosmic accident, how many more are silently drifting through our own galaxy right now? If you want to track these deep space anomalies, show this video with your fellow space enthusiasts. Drop your theories on where these wandering black holes come from in the comments, and make sure to subscribe. Nature has replaced our predictable map of anchored cores with a dynamic wilderness, a space filled with wandering giants waiting in the dark for their next meal.